All right, let's talk quantum physics, but with like a twist.
A
Okay.
twist.
Yeah, twist. Like, have you ever thought about bridging that super tiny world of quantum stuff
Yeah.
with an actual living thing?
Okay, I see where you're going with this.
Like that.
It's definitely a head scratcher. It sounds kind of impossible,
Yeah,
right?
exactly.
Yeah.
But get this. There's this experiment
Oh, really?
that did exactly that. They took a tardigrade.
A what?
A tardigrade. You know those microscopic water bears?
Oh, yeah, right. The ones that can survive, like anything.
Totally. And they tried to make it interact with a quantum computer.
Whoa, hold on. Seriously.
Yeah. It's wild, right? So we dug into a bunch of sources for this deep dive, like scientific papers, news reports from places like space.com, even Cosmos magazine, all about this crazy experiment.
I'm already hooked. So, like, what's the plan for today?
Well, I figured we'd, take a look at what they actually did in this experiment, what they saw,
Yeah.
and why everyone's freaking out about it in like the science world,
Sounds good to me. Let's cut through the jargon and get to the good stuff. What do you say?
Okay, so first things first, tardigrades. I gotta admit, whenever I hear about these little guys, I'm just like blown away. They're microscopic, right?
Yeah, tiny, like 0.2 to 0.45 millimeters when they're just chilling.
Yeah, super small. But they can go into this crazy survival mode called cryptobiosis.
Cryptobiosis, right?
Like hitting the pause button on life. They basically dry out.
Yeah.
Their metabolism goes kaput, and they can survive pretty much anything you throw at them, like boiling, freezing.
Radiation, even the vacuum of space. It's insane.
I know, right? It's like they're from another planet.
Practically. So how do you even begin to study something like that in a quantum context?
Well, that's the crazy part. These researchers in Denmark,
Denmark.
Yeah, Denmark, they scooped up a few tardigrades from like a rooftop gutter.
A gutter. So not like some super high-tech lab.
Nope, just a plain old gutter. And they grabbed these tardigrades, specifically the Rhamazodius virionatus kind.
Interesting. So basic everyday water bears. But why those specific ones?
I guess because they're, known for being super tough. Like the ultimate survivors.
Yeah.
Which is what you want when you're messing with quantum stuff, right?
Makes sense. They needed something that could handle the pressure, literally.
So they took these little guys, and get this, they dehydrated them.
To induce cryptobiosis, right, like we talked about.
Exactly. But then they went even further. They cooled them down.
Cooled them down? How much are we talking here?
To nearly absolute zero. Like 10 millikelvin. Can you even imagine?
10 millikelvin, that's mind-bogglingly cold.
You're right. And here's the kicker. No tardigrade had ever been shown to survive temperatures that low before. Ever.
Wow, so they weren't even sure if they'd make it through that part, let alone anything else they had planned.
Exactly. It was like a huge gamble.
It really makes you wonder about the limits of life, though, right?
Yeah, it's like defying everything we think we know about biology.
So they're frozen solid, practically at the edge of the universe's temperature scale. What's next?
Now for the really tricky part. They take each frozen tardigrade
Okay.
and they carefully place it between these two plates. It's called a capacitor, right?
Yeah, like a part of an electrical circuit.
But here's the thing. This wasn't just any circuit. It was designed to act like a qubit.
Oh, I see where this is going. A qubit. So we're stepping into the quantum realm now.
Yeah. But for folks who haven't, gone down the quantum rabbit hole, could you give us a quick rundown on qubits? Like, what makes them so special?
Sure. So think of your computer, right?
Yeah.
It uses bits, which are either a 0 or a 1.
Like on or off.
Exactly. But a qubit, it can be a 0, a 1, or both at the same time. It's called superposition.
Whoa. That's wild. It's like breaking the rules of how we normally think about information.
Totally. It's like a switch that can be on, off, or somewhere in between all at once. And this qubit, which they called qubit B,
Qubit B, okay.
it has this thing called a resonant frequency. Kind of like, imagine plucking a guitar string.
Yeah, it vibrates at a certain pitch.
Right. And that pitch is its resonant frequency. So they wanted to see if the tardigrade, even frozen solid, would mess with this pitch of the qubit.
So we've got this frozen tardigrade hanging out with a qubit. What happens next?
Well, they didn't stop there. They added another qubit to the mix called qubit A.
Okay, another qubit. Why?
They wanted to link qubit A to the tardigrade and qubit B system.
Why all the linking?
The goal was to see if they could create a setup where entanglement might happen.
Entanglement. That's like the ultimate quantum weirdness, right?
Exactly. It's where two or more particles get so connected that they share the same fate, no matter how far apart they are. Like if you flipped two coins on opposite sides of the planet and they always landed on the same side, spooky action at a distance.
Yeah, that's a good way to put it. So they were hoping to entangle this frozen tardigrade with a qubit. That's ambitious.
Super ambitious. So they set everything up, and then they started watching, taking measurements. And guess what?
Did they see something?
They did. Just having the tardigrade there caused the resonant frequency of qubit B to shift.
Really?
Yeah. So even though it was frozen and in cryptobiosis, this tiny water bear was somehow affecting this super sensitive quantum system.
That's insane.
Yeah.
So even frozen solid, it's still interacting with its surroundings on this quantum level.
Exactly. And then things got even weirder.
Oh.
Well, remember how they linked qubit A to the tardigrade qubit B combo?
Yeah.
The whole system started behaving in a way that looked a lot like quantum entanglement. They saw these correlations between qubit A and the tardigrade qubit B like they were linked.
So it's like the tardigrade was part of this entangled system.
That's what it seemed like. But, of course, things aren't always as clear-cut in the quantum world.
Yeah, there's always some debate, right?
Always. But here's the thing. Regardless of whether it was true entanglement, what they did was still amazing. They showed a real measurable connection between a living thing and the quantum world. That's a huge first step.
Yeah, it's like opening up a whole new frontier of science, right?
Totally. It makes you wonder what other secrets are hiding at the intersection of biology and quantum mechanics. But wait, there's more.
There's more.
After all that, after nearly 3 weeks frozen near absolute zero and exposed to the vacuum inside that chamber, they tried to revive the tardigrades.
Wait, seriously? They thought they might actually come back to life.
I know, it sounds crazy, right? But they carefully warmed them up, rehydrated them, and get this.
Did they?
One of them woke up.
No way.
After being frozen solid near absolute zero for 17 days, this little tardigrade just came back to life.
That's bananas. It's like they have superpowers.
It's a testament to their resilience, that's for sure. But this is where the real scientific debate heats up.
Oh, why?
Well, because some scientists are saying, hold on a minute, maybe those quantum interactions weren't really entanglement. Maybe it was just good old-fashioned classical physics at play.
Okay, I'm listening. What's their argument?
So they're saying that even in cryptobiosis, the tardigrade still has electrical properties, right? Like anything that can store electrical energy.
Yeah, okay.
And they think that those electrical properties might have interacted with the qubit in a way that mimicked entanglement.
So it's like the tardigrade was acting like any other piece of material in the circuit?
That's the idea. They're saying it's like if a tiny speck of dust landed on the circuit and messed with its behavior, you don't need quantum entanglement to explain that, right?
Yeah, that makes sense.
Right.
So are they saying the tardigrade wasn't really entangled with the qubit?
That's their argument. They say that to prove true entanglement, you need to show that the connection between the systems is uniquely quantum and that you can rule out any other explanation.
So it's possible that the tardigrade was just influencing the qubit's environment in a normal classical way without actually being entangled with it.
Exactly. And that's where the debate stands right now.
So we've got this amazing survival story. We've got these hints of quantum interactions. But the question of true entanglement is still up in the air.
Right. It's a fascinating mystery, and more research is definitely needed.
Yeah. But even with all the uncertainty, there's no denying that this experiment was a huge achievement. I mean, they put a living thing into a quantum circuit.
And got it back out alive.
Right. That's incredible. It opens up so many possibilities for future research, you know?
Absolutely. It's like a whole new chapter in the story of science's beginning.
Okay, so to sum up this wild ride with you, we've learned about these incredible tardigrades that can survive pretty much anything. We've seen how scientists pushed them to the limit, froze them near absolute zero, and made them interact with a quantum computer. And then, to top it all off, they brought one back to life.
It's mind-blowing, really.
But the big question remains, was it true quantum entanglement?
That's the million-dollar question, and the scientific community is still debating it, which is a good thing, right? It means they're taking it seriously and trying to get to the bottom of it.
Yeah, it's how science works. Question everything, test your assumptions, and keep searching for the truth. So what can our listeners take away from all of this? Well, first of all, the natural world is full of surprises. There are these tiny creatures out there that can survive things we never thought possible. And who knows, maybe life itself has some deep connection to the quantum world that we're only just beginning to understand.
That's the big takeaway for me. This experiment, regardless of the entanglement debate, forces us to rethink the boundaries between the living and the quantum. It suggests that maybe, just maybe, those boundaries are a lot blurrier than we thought.
It's like everything we thought we knew about life in the universe is being challenged.
And that's exciting. It means there's still so much left to discover.
So here's a final thought for you, our listener. What if the line between the living and the quantum is just an illusion? What if, at the most fundamental level, everything is connected in ways we can't even imagine yet? That's something worth pondering, wouldn't you say?
Absolutely. It's a question that could change everything.
Thanks for joining us on this incredible journey into the world of tardigrades, quantum computers, and the mysteries of the universe. We'll see you next time for another deep dive.